Hello, my name is Dr. Gleisner, and let's do some practicing with the 288 rule. So I've come up with a few examples of what you shouldn't do or what you can look out for in terms of common errors. So what we've got here on the left-hand side are electrons, and on the right-hand side I've drawn 3 shells, and I've not drawn a nucleus because it doesn't really matter. So again, we're talking about the 288 rule, and I've said before that you can look at it as the 2882 rule because you need to accommodate up to 20 electrons, and that's the limit to which you have to go. So there's nothing wrong with this one. This is helium. The electronic configuration is 2. It's got 2 electrons in the first shell, and that is allowed according to the 288 rule. So that's just a nice and easy starter. I will give you some examples of atoms which have been drawn wrongly. I'll pause, or you can pause the video, and then I'll give you the solution to what's wrong with it. Oxygen, the electronic configuration is 2,6. So you've got 2 electrons in the first shell and then 6 electrons on the outer shell. There's a reason why I've paired them up. Please note that this is one atom of oxygen, it's not O2. We'll come to that when we do covalent bonding. Okay, let's start with the atoms that have been drawn wrongly. So if this was oxygen, what would be wrong? I'll give you 10 seconds. Or 5 seconds. 5 seconds is all right. Okay, and you've probably spotted it. So this is oxygen, and you will have spotted that the first shell hasn't got 2 electrons, but the second shell has got 7 electrons. So overall, it still gives you 8 electrons for oxygen, which is correct. But unfortunately, that electron here needs to be in the lower shell in order to make it complete first. So you've got oxygen in group 6, and if you move that back, then you get 6 outer electrons, which means group number 6, and 2 shells, which means period number 2. So this is obvious. I'll give you 5 seconds to spot it. Probably didn't even need that. Yes, there are 4 electrons in the first shell. I'm telling you, this isn't hard, okay? So you can follow the rest of the examples. They're not quite as silly as this. So if I put 2 of those electrons back on the outer shell, then it's correct. This is fluorine, and fluorine has got an atomic number of 9. That means it has 9 electrons. I'll give you 5 seconds. Okay, so this is why I pair up my electrons, because if you count them here, you will find that there are actually 9 electrons on that second shell, and there are a total of 11 electrons, therefore. So there are 2 errors here. Firstly, maybe the student panicked and put 9 electrons because they see the number 9 here in the second shell, but you're not allowed more than 8. And the second thing that might have happened here is that they simply put too many electrons in there because they're not easily countable. So you need 2 in the first shell and then 7 in the second shell. This atom has got 11 electrons. And let's see if you can work out what's wrong with it. I'll give you 5 seconds. And the eagle-eyed among you will have spotted that the third shell is empty. So this outer electron should have gone on the third shell here. So it's 281 is the electronic configuration. The reason why that is important is because sometimes you get a pre-drawn atom, maybe with 3 shells, maybe with 4, and you need to put the outer electrons in the correct shell. Okay. So this is the last one, I think. This is scandium, number 21, and I'll give you 5 seconds. This is a trick question. While you can see, beautifully counted out, 2, 8, 8 electrons, and then 3 on the outer shell. But the trick here is that we only need to know the first 20, and scandium is 21. So the last one that you need to know is calcium, and calcium has only 2 electrons on the outer shell, and the one before that is potassium, which only has that 1 electron, so not those 2, but that 1 electron on the outer shell. Calcium would be 2882, and potassium would be 2881. So I hope you find this useful. and I'll see you in the next video. Please like and subscribe and let me know of any questions you'd like me to cover in the comments.